What are black holes? A black hole is a region of space packed with so much matter that its own gravity prevents anything from escaping, even a ray of light. Although we can't see a black hole, the material around it is visible. Material falling into a black hole forms a disk, similar to a whirlpool in a bathtub drain. Matter swirling around a black hole heats up and emits radiation that can be detected. Around a stellar black hole, this matter is composed of gas. Around a supermassive black hole in the center of a galaxy, the swirling disk is made not only of gas, but also of stars. Stellar black holes form when the center of a very massive, dying star collapses in upon itself. This collapse may also cause a supernova, or an exploding star, that blasts the outer parts of the star into space. If the core remaining after the supernova is very massive, gravity completely collapses the core into a black hole with infinite density. Black holes created by supernovas can be about 5 to 50 times the mass of the Sun. Only stars with very large masses can become black holes. Our Sun, for example, is not massive enough to become a black hole. 5 billion years from now, when the Sun runs out of the available nuclear fuel in its core, it will end its life as a white dwarf. Hubble's ultraviolet instruments detect the particle winds coming off accretion disks from stellar-mass black holes. As light from the disk moves through the winds, some of it is absorbed by material in the wind. Disk winds turn on when a black hole is gobbling material nearly as fast as it can. These eating binges usually happen in a matter of months, unlike with supermassive black Supermassive black holes. Stellar black holes are minuscule in comparison to the beasts that astronomers think lie at the centers of most galaxies. These black holes are supermassive, millions to billions of times the mass of our Sun. Prior to Hubble, astronomers did not have conclusive evidence that supermassive black holes existed in the universe. Thanks to Hubble and other observatories, we now know that supermassive black holes are intricately tied to the evolution of the galaxies in which they reside. These black holes formed at the same time as their host galaxies. They are thought to have grown from seeds from the earliest massive stars. When astronomers first turned radio telescopes on the sky, they tracked radio wave sources to some typical cosmic objects, including the remains of supernovas, distant galaxies, and powerful areas of star birth. One particular type of object looked like nothing more than a point of light, perhaps a star. Further observations showed that these objects were extremely far away, meaning they could only be in very distant galaxies. The objects, called quasars, were thought to be the incredibly bright centers of those faraway galaxies. We now know quasars are the small, but intensely luminous, bidirectional beacons of light produced and powered by supermassive black holes at the centers of galaxies. Galactic material such as gas, dust, and even stars, if located too close to a black hole, will succumb to its relentless tug of gravity and be pulled inside. As this happens, the infalling material stretches, heats, and accelerates, creating enormous forces near the event horizon, the point of no return from the black hole's pull. These forces produce powerful, twisting magnetic fields that launch jets of material at near the speed of light and stretch thousands or even millions of light years across. The intense forces create strong radiation across the spectrum, from gamma rays to radio waves. The distance to quasars is so great and their actual size so small, about the size of our solar system, that the mere fact that we can see them via telescope makes quasars the brightest objects we've discovered in the universe. In fact, one of Hubble's contributions to the quasar mystery was to prove with its high resolution there actually was a galaxy hidden behind the glare. Hubble observations also helped determine that these brilliant galactic centers are powered by supermassive black holes. Hubble found How does Hubble find black holes? Many of Hubble's first observations showed the effects of supermassive black holes on their immediate galactic environment. In 1990, shortly after launch, Hubble imaged a 30,000 light-year-long jet emanating from a galaxy known to be a prodigious emitter of radiolight. With Hubble's observations, astronomers had the data they needed to determine that these jets come from very small regions in the centers of galaxies and are likely powered by supermassive black holes. Hubble's fine resolution, the ability to see tiny details, helped propel the case for supermassive black holes even further in 1994, when astronomers took spectra of the gas in the center of the elliptical galaxy M87. Spectra, or the breaking up of light into component colors, can give astronomers a great deal of information about the gas, including its velocity. Astronomers noted that in M87 the central gas was circling in a disk at very high speeds around a small but massive object. The only type of object that can be that massive and yet very small in size is a black hole. These observations by Hubble helped confirm nearly 2 centuries of theories and conjectures about the existence of black holes. The Space Telescope Imaging Spectrograph, STEES, an instrument installed on Hubble in February 1997, is the Space Telescope's main black hole hunter. A spectrograph uses prisms or diffraction gratings to split the incoming light into its rainbow pattern. Each element interacts with light in a unique rainbow signature. The position and strength of those signatures in a spectrum gives scientists valuable information, such as how fast the stars and gas are moving. STEES can take a spectrum of many places at once across the center of a galaxy. With that information, the central mass that the stars are orbiting can be calculated. The faster the stars go, the more massive the central object must be. How does a supermassive black hole affect its host galaxy? From the wealth of Hubble data, astronomers now understand that black holes can have profound influences on the galaxy as a whole. For example, the jets from supermassive black holes can propel massive amounts of gas and dust into intergalactic space, thus ridding the galaxy of much-needed fuel for ongoing star formation. Or in the case of a 2015 result using Hubble observations of large elliptical galaxies, jets from supermassive black holes may regulate star formation in such a way that it keeps going, albeit at a slower rate. Perhaps the most surprising result from Hubble's observations is that supermassive black holes must reside in the majority, or even in all, galaxies. Once the objects of extreme speculation, supermassive black holes are now considered integral components of galaxies and crucial to the study of how galaxies evolve over time.